Good evening, everyone. You're welcome once again to another section of CoTribe PLD. My name is Abiodun Shitu. I'm from Cohort 8. And for this section, we'll be talking about shell permission. And the person in charge of this section is no other person, my colleague, also from Cohort 8. He goes by name Samuel Adeyemi, aka Samfodo. So the floor is yours, sir. Mr. Samuel, carry on, boss.
Good evening, everyone. My name is Samuel Adeyemi. I'm from Port 8, and it's nice to have us here. I'll be taking us on shell permissions this evening for the next 1 hour, 30 minutes or less. So, basically, when we are talking about shell permission, of course, that consists of two words. We have the shell and we also have permissions on the other hand. That means we have to know what a shell is and also have to know what permissions is. So let me start with permissions. When we're talking about permissions, of course, just like normal English language, it could refer to the type of control that you have over a particular thing. So now let us now bring it home to when we're talking about shell permission. What is a shell? We know that our shell, as we have been using, is that program that can take our command or our inputs from our keyboard and it will perform any operation we want you to perform. It can understand commands that like make sense to it, commands that we already know, that we've learned, that make sense to the shell program. So we can input such commands to it and it makes sense to it. Now, when we're not talking about shell permissions, it's not referring to the control that we have over some of the programs, or in this case, can refer to even a file in our shell terminal, the permissions, the controls that we have over that file. So that's just basically what we are going to be going through this evening. So to begin with, I will like to tell us why we actually need to know this and why this is important, because you might be wondering, why should I know shell permissions? What is the use? You actually need to know it because as a programmer, or let me just go back to the olden days when people still when computers are not this rampant that we have it in our world now, where a whole institution might have just a single computer. They have access to just a single computer. I'm talking about maybe the 1950s, 1960s, and stuff like that. And then different users will be using that computer. Let's assume we are in a school setting now. Let's say we are in a university setting and we have a lot of lecturers, of course, in the university. And then the lecturers only have access to one central computer that the whole university is using. So that computer, lecturer A will come. You might want to set his test questions or his exam questions, and he will come there, we type it bang, 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 on the computer. He will send the questions. Then lecturer B will come, he will also do the same thing. Now, the purpose of shell permissions is that when lecturer A should set his own exam questions, no one apart from him should actually have access or rights to such questions. In fact, he can set his own test questions in such a way that even if another person should come and use that same computer, the person will not be able to access or actually use or even view the files that he has already like put the contents of the files he has on the computer, even though they are using the same computer. So therefore, different users can be using a single computer, which means that they will each have individual different, should I say, logins or passwords or stuff as that, their own group on that computer, their own how will I put it? Just like our own normal laptop, you can have a particular window, then another person can be using the same laptop. He will have his own particular window when he wants to log in, where he's going to input his password. You can have different windows like that at the point of entering your password. So the same thing is applicable here. The purpose of shell permissions in a nutshell, everything I've been saying since morning, is simply that shell permissions is as a way to actually, it's like a security feature in a sense that has been in place for Unix like computer systems, and it is still being used up till today. And it is important as programmers that we actually have knowledge of it. So therefore, let us now get to the programming aspect of shell permissions. So please permit me to share my screen, and all the stuffs I've been saying since will now actually make sense to us now. Okay, so I'll be using a this is my Git bash. So just permit me to SSH into my Vagrant. And I will cd into a directory which I've created earlier. I'm not yet in. Okay, I'm in. Okay, let me just list the files.
Please,
I'll cd into.
can you zoom in a little bit?
Okay, it's better like this.
Yeah, better. Thanks.
Okay, so let me just cd into PLD. Okay, there are no files here. So when we are talking about file permissions, let me create a file for you and let us show you the. So of course we know it is the touch command we are going to use to create a file. So let's just name it file 1. Let's say we want to create a file and let us name it file 1. File 1, okay, yeah. Okay, let me create another file called file 2. With a single touch command, you know I can create multiple files. You just me putting spaces, a space in between them. So when I click enter and I do ls to list the files in my current working directory, of course I have 2 files just using a single touch command, and I can do it individually. I can do touch file 1, I type again touch file 2, but why go to the long method when you can use the short way? So now, file permissions. You can check file permissions of these 2 files I just created now. You can use the ls -l command. This ls, as you all know, is a command to view the files in your current working directory, but you can pass a flag to that ls command, the -l. The -l means show me this file, so in my current working directory in a long format, meaning that it's going to list them from top to bottom. Just our normal ls will list the files from left to right, like this, like this, like this, depending on the number of files. But our ls -l command will actually do something different, and it will show us more information about that file. So it is still showing us the 2 files. This is it, file 1, and we have the second file here, file 2. But you can see some gibberish, whatever that is here. This is exactly where we are going this evening. What these stuffs mean, we are going to get to know them now. So I just use the ls -l command, and you can also use, I think, ln. It takes, it works also the same way. Okay, I think ln will also give you hidden files in your current working directory. Okay, so now let me just let us use ls -l so as not to confuse us. Now we have 2 files here, file 1 and file 2. Now when we are talking about the permissions of this file, let us start with file 1 that we have here. Now look at it. Can you see this dash rw dash r whatever up to this last dash that we have here? This is actually the permission of this file called file 1. Now let me explain what these things means. The first dash you are seeing here will actually tell you the type of file. Don't let me say the type, the nature of what you have of this thing called file 1. Now we have a dash preceding the R. If you can list a file like this using the -L flag, and the first thing starting it is the dash, just know that it is a file. It will make sense very soon. Just calm down. If you can see a dash as the first thing starting it, just know it is a file. At times, if you do ls-f flag, you are going to see a D starting it. If it starts with a D, it means it is a directory.
How about we create a
But if it
directory
starts,
just to
yes, I was
for,
going to do that.
okay.
So let's just say directory. Let's just name it directory. So once again, we use the ls-l flag. Now, even merely from the color, you already know. But even if you don't want to use the color to know, you can still come here and check out the properties of the directory. Now you can see it is starting with a D. So automatically this is telling us that this guy here, which is in something like blue color, is actually a D. A D starts for a directory. But these our two guys here, file 1 and file 2, they are starting with this dash. They are telling us they are files. It is not a directory. Now, if you count all these stuffs to the last one here, they should give you 10. The dashes, they should give you 10. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the first one out of the dashes will signify if it's a file or a directory. The second till the fourth one. Now, this is it. This is the first one. We are no longer, I've already explained the first one. What the first thing will tell you, we either tell you if it's a file or a directory. If it's starting with a D, it's a directory. If it's starting with a dash, it's a file. Now, it's remaining 9. 9. So we're going to divide the 9 into 3. I will come again. It's remaining 9 different, whatever these things are, that is showing us the permissions of this directory. We are going to divide them into groups consisting of 3. That means we are going to start with the first group, which is what? RWX. That's 1 permission. Then we now start counting from the next 3, RWX, which is another permission. It means another thing, which I will still explain later. Then we now start with R-X, which is also another thing. So what exactly are all these D, R, W, whatever? Please just permit me to quickly write this out inside file 1. So I will cut it out and we'll be seeing. So if I just say it, you can always reference it when I cut it out on the screen. So the first thing, D, this shows it is a directory. And I told you it always starts whatever content is your current working directory. So we have W. In fact, I should space this. Sorry, let me just space that out. Okay, this shows a write permission. It's still going to make sense now. The next one we have, okay, I should start. Oh, sorry, let me start with R. Follows the pattern of R, W, X. So let me just start that. This shows a read permission. And the last one is the X. This shows an execute permission. All these will make sense in a minute. So now let me cut out the file. 1. Good. So we've already explained this. If you use the ls-l flag and it's starting with a D, then you know this is a directory. If it's starting with a dash, automatically you already know that's a file. Now let us go to what R means. R in a file permission means that it has a read permission. What is read? It means you can actually open a file for, let's talk in terms of files now. You can actually view the file only. That's what read means. You can view. You open the file, you view the file. That's what R means. Any file that has R permission, it means you can view such a file. There are some files, if they don't have R permissions, it means you can't view them. Now, what does W mean? We said it means write permission. It means you can edit that file or the contents inside that file. It can be edited, adjusted, you can add more to it, you can remove, delete, whatever you can do. It will have the ability to be edited. That is what the W here means. Now, what is X? X permission means it has an execute permission. I think we understand this better when we start running programs. I will just show us one brief example of X when I actually get to the point where we need to discuss more about X. But it means execute permission for a file. So what does X now mean for a directory? Okay, maybe when we get there, I'll talk about that. So that I will not confuse us with what execute means. When we get there, when we get to the bridge, we'll cross it. Now, the other time I said everything here consists of 10 different, should I call them alphabets now? No, they are not different, but they consist of 10 possible alphabets. Don't let me say different. You can always have, okay, you said? Okay, thank you very much. So we can have a possible combination of maximum of 10 possible characters showing the file, the shell permission for whatever entity you have inside your working directory. So the character D, of course, signifies the directory. Now, I said we are going to split the remaining 9 into groups of 3. That means RWX here means something. RWX here means another thing. Then R-X means another thing. Now, the first 3, or don't let me call them 3. I will call this one, I will call D1, I will call R2, I will call W3, I will call X4. So I'll be talking in terms of numbers now. From permissions 2 to 4, I believe you are following. From permissions 2 to 4, which is the RWX, which I will call first group. The permission there refers to the file owner permission. Who is the file owner? The other time, I started with an illustration of a lecturer who went to the single computer system they have in the whole institution, let's say in the 1950s, and he went there, posted, created a file, wrote the questions for his test or exam questions or whatsoever inside that file. Now, this RWX means the permission for the man himself. You, the owner of this, okay, in this case, this is a directory now. So as I am here on my own system, this RWX refers to my own permission. In other words, it means I can read, write, and execute this directory. Once again, numbers 2 to 4 signifies the file owner permission. As the file owner, I can RWX this file. R stands for read, W stands for write, X stands for execute. But in this case, when we are talking about executing a directory, it doesn't actually mean running a directory. It just means you can CD inside it. That's just what execute could mean for a directory in terms of directory. Now, this is numbers 2 to 4. Now, let us start from numbers 5, from this guy, 6 and 7. So, characters 5 to 7, or numbers 5 to 7, they also refers to another permission. What do they mean? They refer to the permission of a group in which the file or the directory belongs. They refer to the permission in which the file, they refer to the group permission from which the file or directory belongs. So, in other words, it means characters 5 to 7 refers to group permissions. So, what is a group? A group is just like when we say we group something, it's like a general place where files can belong. In this case, if you want to know your group, okay, I'm still going to get there. Let's continue. But numbers 5 to 7 refers to group permission. For this, I'm also a group user on this my system. I'm going to show you now. It's already on the screen. So that means someone who is in the same group. Okay. The first thing you are seeing here, I think this will make me explain better, refers to the file owner. This guy here, Vagrant, is the file owner. This other guy here refers to the group. This is the user. My own name is Vagrant because I'm inside my Vagrant machine, virtual box. And this other Vagrant here refers to the group. That means for someone who is in group of Vagrant, starting from characters 5 to 7, the person has a read permission, the person has a write permission, the person also has an execute permission for this particular directory. Now let us go to the last 3. Characters 8 to 10. What do they mean? They refer to another group permission on their own. In this case, it refers to others permission. Others could be anyone, like whatsoever, any random person. What that person, the permission the person has over this directory. So let us now use the analogy of that lecturer that we used the other time. Characters 2 to 4 refers to the lecturer himself, the user permission. I have, I'm the owner of the file, owner's permission, I said user, or your user or owner's permission. So I have this permission, read, write, execute. For group permission, the RWX, that is characters 5 to 7, when we are talking about group in this sense, we can say the lecturer and his other co-lecturers who are in the same, let's say, department can have access to this directory. That is, they are in the same, let's say the lecturer is in faculty of, let's say, education or something. So all lecturers in faculty of education, we have access to this directory. They are in the same group, but it's only the lecturer that has this access. But yeah, you can be looking at it that maybe it is the same. Don't worry, we'll soon get to a point where the user, the owner's permission and the group permissions can be different. But for this instance, you can be looking at it that it is the same. So it doesn't really make sense. It will soon make sense as we move on. Now the others, I said it can be anybody. In this case, it can be me. So let's say I happen to use the computer system of that institution and I went there. So the only permissions I will have on that directory that the lecturer created, let's say the lecturer was the one that created the directory, this is the permission I will have on that directory. It means I will only be able to read and execute the directory. I don't have any permission on the directory. You can see it's a dash here. There's no W here. So that means with your mind's eye, you should be able, merely looking at this my shell terminal now, you'll be able to tell me the group, the owner's permission for any file, the group's permission for any file, and the other's permission for any file. So I want someone who is confident enough to use the raise hand button. I'm going to call on someone, and the person is going to tell me the file permissions that we have for this file 1 that is displayed right here. So if you are sure, you can tell me. Okay, I think, okay, let me just check that right now. Okay, which one am I seeing? Okay, let me just call the first person here. Komolafe Olua Sheyifumi, please. The names, okay, thank you very much.
So Komolafe,
So,
you can unmute your mic and talk.
yeah, yeah. Okay, so can you hear me?
Yes, we can hear you. Go
Kind
on.
of.
So I think for the permissions are the first thing for when there is a file in the and you can maybe you can write for example
I
I can't
second
really
one
hear
sorry,
you clearly.
your audio
you can
feedback is
write
bad. I
in
don't
terms
know.
of code.
Oluwaseyi, your audio feedback is bad. I don't know if you're using a mic. Are you using an headset or
Can you hear me
something?
now?
Yes, we can hear you now.
Can you hear me now?
Yeah.
Loud and clear.
Yeah, I've changed to can you hear me now?
Yes, you can go on, please.
So like I said, for the first part you can read, you can write, or you can execute. For the second, as the user, for the second as a group, you can read, you can write, and you can execute. And for the third as order, you can read, you can write, and you can execute.
Thank you. That's perfect.
That's all.
Thank you very much. So that's it. And the same thing goes for this other file 2 that we have here. The first dash here is telling me this is a file. It's not starting with a D, so I won't call it a directory. The characters 2 to 4 is the user permission. It's showing me the user has a right. The user has a read and write execution permission for this particular file 2. Then characters 5 to 7 here is also showing me the group has a read and write permission. And the last 3 characters 8 to 10 is showing me others has only read permissions for this file. So that's just the basic summary. Then I said this guy here means the user, that is I that I'm here, Vagrant. Then this other one refers to the group that is here. And if you want to know the groups I have, I think there's a command for that. Just type in groups. It should show us the groups that we have. Okay, we only have the Vagrant group here. So it's showing me the group that I have here right in my virtual box. And this is showing us when I created the file. This directory, when I created this file, I created it now. It shows us the time and the date. And at times it will tell us when it was last edited, or when last you performed an operation on it. Now let us get to the point now where we will start changing the permissions of our directories or our files. There is a particular command which one uses, they call it change mode command. And the beauty is this: before you use this change mode command, chmod, that's the short form. The full form is change mode. And before you use this command, you actually need to know how to use it, which format it follows. So of course, as programmers, we need to do what? We need to check our manual. So let's do that right now and see how we can use this command. Okay, chmod means change file mode bits. So synopsis, it says we can use it in what? In 3 ways. Number 1, we can write our change mode command with an optional flag followed by the mode ellipsis, that is continuous mode. Then we signify the file ellipsis continuous files. That means we can use this chmod command to even change the mode of more than one file at a time. That's what this dot means. And this first mode at times could refer to our user. The second mode refers to the group. Optional others. Don't worry. When we start using it, it will make mode command. You understand better what this particular first line is saying. I just want to show that the different ways in which you can use our chmod command. Then the second way is this: you use our shmod, optional flags, ellipses, that is continuous. You can have more than one optional flag. That's what this dot 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 is telling you. You can have whatever flags, which we see have when I go down, you see those flags that we have. So this is called the octa mode file. What is octa mode? We are going to see very soon. Then the file name dot dot dot, that is continuous as possible as you have. The third way is using the reference method to change the mode of a file. What reference method is just saying is that you want to change the mode of a particular file with reference to the mode of another file. I want to change file B. I want to change file B's permission to be exactly the same thing as file A's permission. So this is when the reference method comes into play. So basically, we have three methods of changing the modes of a file. The first one is using, let me just say the normal method that I know that is very common. That is using the chmod, your optional flag if you want to use. Then you type in the mode you want to put in. Then the other method is using the octa notation, and the last way is using the reference method. We are going to show us these three methods, but your own, please, you can go and do what? Read the rest of the manual at your leisure. Our time will not permit us to do that right now. Those optional flags I talked about are down there. Okay, in fact, I'm seeing something interesting here, which can help us with the explanation. So it says the format of symbolic mode. Okay, good. That's the name for this first method that I called the common method. It's called symbolic mode. So it says the format for symbolic mode, we use these guys here, UGOA. What is U? U is users, that is I, the owner of that file. G means what? Your group. O means what? Others. A means what? All. So A is the combination of U, G, and O combined. That's the meaning of A. So using the symbolic method, you can only pass in these alphabets, U, G, O, or A, as you so desire. So I think I should write these guys out. Then after using these guys in the symbolic mode, you specify whether a plus, a minus, or an equal to change the permissions. U stands for users, G stands for groups, O stands for others, A stands for all. There are different ways to go about it, but let me exit this now. And okay, let me clear my screen. And let us get our hands into the real coding aspect. So the first method I talked about is what? The symbolic mode. So let me just quickly veer into one being okay. Let me just leave the space. So we have the U signifies, now this is symbolic mode. Please take note. Symbolic mode. That's the first and the most common method out of the three methods that I spoke about. So the U refers to the what? User. That is I, the one who owns the file. The G refers to the group. In fact, I should even put it on a single line. U refers to user, B refers to group, then O refers to others, A refers to all. That is combination of everything. Now, let me put that as this. So let me save the file, cut it out. Now, we said U refers to users, G refers to group, O refers to others, and A refers to all. Please, I want us to get this very clearly, because from here, when we move to the second method, the octa notation, it can start to get a bit complex. But if you understand this symbolic mode very well, when we now get to the octal method, it is going to help us to understand even more better. So please let us try to get what we are trying to do now. So let me use my ls minus l to list the files. Now let us try to change the permission of this guy here, this file one, for a user. How do you know the user? You already know the numbers 2 to 4, characters 2 to 4 refers to the user. Now looking at this guy, the user only has the permission read and write. Now let us do something. Let us add an execute command to the user for this file one. So how do you do that? Using the symbolic mode, we type our change mode command. That is the first thing you are going to type. According to the manual, we can have parameters. But in this scenario, we are not using our parameters. We don't need any parameter for now for our level. So we skip that parameters. And what is the next thing that will follow? The mode. So what do we want to do? We want to add an execute permission to the group permission for the user permission, I mean, for this file. We want it to have an execute permission. So how do you do that? X permission. So you start with your, okay.
Yeah, I'm calling our this thing, start time liaison. Hello, can you hear me? I'm calling our start time liaison this thing officer.
I'm sorry for that. So we're saying we want to add an execute permission for the user. So what you will do is you will type your chmod command, then user plus x space, then the file you want to change the permission, file one, you input that in. What I just typed there is that change the mode user plus x. That means add an execute permission to what? To the user. For which file? For file one. So it follows this format. Your what? Your change mode command, then your mode, then what? Your file name. Of course, here you can have optional parameters, but I said we are not what? We are not using any optional parameter in this instance. We already checked our manual the other time. As your layer, you can go back and reference it. So for the symbolic mode notation, this is how you change the mode of a file. Now let me tap press enter. Of course, we are not getting any error. It means it is successful or highly likely successful. So now let us use our ls-l command again to actually check to list these files in a long format. I mentioned what -l flag does the other time. Now for file one, the first thing we notice is that the color has changed. It's still a file. How do I know? Because it is starting with a what? With a dash. Even if the color should change to blue, as long as it is starting with a dash, I won't call it a what? A directory. Of course, I'm just joking. It shouldn't change to blue. But just so you know, this is the best way to know if anything in your working directory is a file or a directory. If you are not good with colors, just come here, use your ls-n or type ln to actually check the permissions of your file. Now, what did we do? We added an execute permission for this file. It's changed the color. Fine, very good. But now come here. Execute permission for what? For the users section. Where's the user section? Characters 2 to what? To 4. Of course, RWX. Come back here. We only have a what? The RW here. RW and dash. But here it has become RW and X. This is to show us that this command we just typed there to change the mode of file one actually worked. So this is one way you can use to do what? To actually check and see if you have actually changed the permission of a file. So this means that I, as a user of this computer, that is Vagrant, this is me, I can actually execute this file right now. Before, I won't have the permission to execute it. But now, I have the permission to do that. And the other time, I was talking about execution. In fact, let us do execution last. Let us come and play around with read and write permission. So now, I want to work around with file 2. I want to remove the write permission I have as the user. As the user, I have the read, write, and I only have read and write permissions for file 2. I want to remove the write permission, and I want to show you something. If we'll be able to write inside the file. I'm still the owner, but I want to remove the write permission for Vagrant. That is I. And let us see if I'll be able to write into this file. So how do I remove? It follows the same method. You do what? You type your chmod command. What do you want to remove? Is it U? Is it G? Or is it O? This guy is here. U for user. It only affects users side only. G for what? For group. It only affects group side only. And O for what? O for others. It only affects others side only. But in this case, we want to do that of what? For user. So therefore, I'm going to do what? User. I want to remove what? The write permission. How do I do that? I use a minus as against a plus that I used here. Plus is like addition. Minus is like subtraction. You want to remove. You want to remove the permission, so you use a minus. If you want to add the permission, you use a plus. So therefore, for users group, remove which permission. I'm going to type the permission right here. I want to remove what? My write permission. So therefore, I'm going to type W. Then I'm going to type the file name. Okay, so let's press enter. No errors. So once again, let us use our ls-l command. So before we executed this command for file 2, this is the group, this is the user permission, read and write. Now we remove the write permission. Let's come and check here. Now we can see it has become only r dash dash. For the user of this file 2, we only have the write and the read permission. If you want to add it again, same thing. But in this case, you are going to do what? Put a plus. Then let's do the ls-l. Once again, you can see the W is back there. So it's very, very simple. This is the simplest way to actually change the mode of a file. It's as direct as this. Whatever you want to add, whatever you want to subtract, you indicate it, type in the file name, and go on. So now, let us, okay, let me, okay, for file 2, we already have the write execute. Okay, before I remove it, let me write into the file. So let us use our VR for file 2. Quickly, let me just show that I am writing inside file 2 with a write permission for the user. Therefore, when I exit this, I can save it. Let me cut it out to show you it's really, really there. Can you see? I've written inside file 2. Now let me remove the write permission just to show you how effective this is, because the other time we said file permissions can be used as a security feature. So therefore, let us remove the write permission. Using the up arrow key, I can recall previous commands I have typed. So I don't need to start typing chmod again, since I've already typed what I'm looking for before. So this is what I'm going to type now. I'll press my enter. So of course, I've expected that the write permission for file 2 is already gone. Let me confirm that to show us. You can see we only have the read permission for the user side. Now let us write inside. As user, Vagrant wants to write inside file 2. Let us see if Vagrant will be able to do that. Very good. In fact, can you see? It says what? Read only. There's only a hard permission for this file. It is telling me I can't write. I can't edit this file. If I try to do that, I won't even be able to do that. But let me try. I'm pressing my insert key now. Warning, changing a read-only file. Okay, let me start typing. Let's see what will happen. Will I be able to save and exit? Let's go on. I just edited this file, but stuck here. That's the truth. I can't save and exit this file. Let me press my escape button using my semicolon, using my W, Q, enter. It's not working. It says read only option is set. Add whatever to override. Okay, it says I can override this, but that means I'm going to actually go against the permission as the user. And the reason I have the right to override this is because I am the user. But this is just to show us that using the file permission, I am kind of like stuck here because I've edited this file. I can't save and exit using my WQ syntax for my VI text editor. One of my keys are even working right now.
I'm not sure.
So therefore,
I'm not sure if that exclamation mark will be able to
override what? Override it,
because that one is
okay,
just an option.
Okay.
It's just an
to exit
hint.
without saving.
It's just an hint given to you by the VI editor. So even if you try to use the exclamation to override, I doubt if it's going to override the right permission that you removed from the file. Yes. You can try it. Just type :WQ with that exclamation mark.
I think exclamation mark means exit without saving. So if I cut it out, it's going to just exit it without saving the file. So let us check that.
Oh, it actually did override.
It's not something inside.
That's nice.
Let us check the file permission for this file. So you see a read permission. Wow.
We've learned something new.
But in the real sense, let me edit it again. I try to exit that. Okay, it's still giving me this error that it's a read-only file. This just to show you that it can serve as a security feature when we have already set a permission for a particular thing. And I believe the reason I'm able to override this is because I am the one that created the file and I'm the user. Maybe perhaps if it is for others, maybe others who randomly, maybe I put this file to GitHub and maybe they probably downloaded it and they try to edit it on their own VS Code, maybe they will get an error, yes, and they will not be able to override it. But because I'm the one that created this, it's giving me the option to override what the limit I set on this file. But using my normal method of leaving VS Code, I won't be able to exit this file in the proper manner. I'm just going to exit without saving. It's still telling me to put this guy. Okay. So, okay, thank you very much. So let's play around with, let me cut file 1. Let me cut file 2. Let's play around with changing the modes of our files. So I've already done that of users. So we do that of group and I'll do that of others. Then, and we'll also try this out. Then I'll just ask us 2 or 3 questions. Then we'll move on to the second method, the octa notation of changing file modes. So now, okay, we've changed the chi mode. Let's say we want to change file 1. Let's say we want the others to have, it's only having a read permission. Let's say we want to add write and execute permission for the others section of file 1. So the same thing, chi mode, we are going to what? To others. So we say O plus what? We want to write plus W. Then you can even say plus again. And execute. You can use this method. You can keep adding plus, plus, plus. You know, the other time we said it as dot, 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 and so on and so forth when we take the manual. So it's the same thing we can have here. We can say plus W plus X. And I can decide to even add plus R, even though R is there. If I wish, I can add plus R. If you just for the fun of it, it's already there, So you are just like a repetitive command, but it's not necessary. So therefore, let me type that as file 1 and let us see. So ls minus l, file 1, where are you? File 1, file 1, file 1. Okay, chi mode. What did I type? Oh my god. It was for file 2, sorry. I thought it was file 1. Okay, still the same thing. We can see the others permission now for file 2 that I typed here. I added W and X, that is write and execute permission for others. Others is just anybody, any random person that comes across this file, wherever the file is. So we can see we have the RX, we have the WX added. And if you want to remove the RXW, the read, write, execute we have for others group, the same thing, you do what your chi mode, but this time around you put your minus, you come here, change it to minus, you come here, remove our read, then minus. So this way we said change the mode of others by removing what? Read permission, by removing what? Write permission, by removing what? Execute permission. For which file? For file 2. Pressing enter here, using our ls minus l, we expect the others permission, that is characters 8 to 10 should be what? Should be blank. We remove complete permissions from what? Others section of file 2. The same thing, you can come and remove the permission for the what? For the group section of file 2. The same process you are going to follow, but here you are going to do what? You are going to say remove group. Here we already have read and write. So this X is actually not needed, but let's just leave it there like that and let us see what will still happen. Here we are using what? The G option. G what stands for group. So therefore press enter, ls minus l. Once again, you can see it is gone. This is it. Characters 5 to 7. You can see there's no longer a permission for what? For the group section. Unlike we have it here, which is the read, write, and dash. But yet it's what? Completely blank. Likewise, for the users section, which has the read permission, it has only read permission for users. The same method, just come here, remove what? The read permission we have here. We say user minus what? Read permission, file 2. You press enter, you list your files in a long format, and you can see the user's permission, the characters 2 to what? 4 is already what? It's already gone for file 2. So this is just basically how you can play around with the file permissions you have on your system or your working directory. You can change your file permissions. You can do that for file 1, and you can do that for a directory as well. But what you just need to know is that you have to know the content of this file 1. That is, your read shows read, your R shows read permission, your read shows write permission, X shows execute permission, and you have to also know what U stands for, what G stands for, what O stands for. Oh, we did not try this A. Come on, let us try this. Let us try this out. Good. So for file 2, we can see, where's file 2? Yes, we can see we don't have any permission here. So I said A means on. So let us try A. Once again, we use our chi mode. So here we are going to do what? A plus all is a combination of U, G, and O. That is user, group, and others. So therefore, let's say we want to add read permission for them. Then we also want to add our what's that? Oh, we want to also add our write permission. I also want to add our execute permission for what? for all in group what in file 2. So typing this in, no errors. Therefore, let us use our ls minus n in a long format. Therefore, you can see that everything is what is back for all. We just added read write execute for users, read write execute for group, read write execute for others. So that's basically everything for symbolic mode of file permission. So let me just ask, like, okay, let me try something. The other time, I was saying when we remove the execute permission for a directory, we shouldn't be able to see the inside it. I haven't actually tried that, but let me try that now. Yes, I said I wanted to try something too. Let me try this first before we. So let us remove the execute permission for this directory. So instead of me removing for user group and others, I'm just using the A flag. Yeah, I did a mistake there. For what's the name? The name of the directory is directory. So I'm using this. Okay. Oh, it's not changing. Okay, it has changed. There's no longer execute permission. So let me try to see the inside it and let me see if I'll be able to see the inside it. Okay, it says permission denied. So when we are saying executing a directory, it just means we cannot enter into the directory. You can see that permission denied. So let us give back the permission now and use the plus sign. So we just change the mode of the directory. So let us check. You can see the directory has an execute permission now for all. And let us try to see the inside the directory. Good. I'm inside the directory using my print working directory command. You can see I'm inside the directory as my last part that is being shown here. So just showing us that you can once again I said your file permissions can serve as a security feature. You can use to prevent intruders from spying or accessing what they don't have access to. So let's go to what does it mean to execute a file.
Sorry, please. Before you go on, I just want to add just a little thing. The part where you were adding the whole execution and the whole permissions from a single file with a plus r plus w plus x, just with a plus this one. You can as well just do a plus rwx instead of using plus plus plus.
Okay.
Yes, you can try it with minus, just a minus rwx. It will remove all the words, all those permissions. You can just try with minus just to demonstrate what I just said. Yeah. So it means that what you want to perform this, you want to set all these permissions on this what, on the all the users of this computer. So
thank you very much. That reminds me, there's also another way to go about this. We can also say something like this. Our chi mode, we can say you, let's say same thing this all will do. Okay, the all. Let's say we want to just do it in the long way, or maybe we don't want to do all. Let's just say you use the equals to command. Let's say you want to add x plus r for user, use a comma. We say this for user, you want to add and execute and write command permission for user. Let's say for your group, you want to add, let's say, a read plus write plus execute. And let's say for others, you want to add, let's just say, only read permissions. So let's say it is varying. So instead of using all in this case, all will change for everything, but the permission for user, I want it to be different from the permission for group. I want the permission of others to be different too. So you can use this format, specify your file name, file 2, and let us see. So the same thing. You can see file 2 now. For user, as you specified, it has an X plus R. For group, it has a read write execute permission, as you can see here, and for others it has only a write permission. So there are various ways around this, but the thing is, like I said, if you understand this concept, you'll be able to understand where we are going next, which is a bit technical than this. So just before I move on to that, okay, let me try what he said just now using removing the plus this time around. Okay, in this instance, let's just say, oh wow, let's just say we want to set everything to, let me just run around this. User should be, let's say, only execute for file 2, or let's say only write, since there's no write there. So let's just try this and see if, okay, no errors, therefore it's working. Okay, this can also work. User is equal to W, and so on and so forth. So I was talking about what it means to execute a file. To demonstrate this, I will just write a very, very simple bash script that lists what you have in your current working directory inside file 2, and I will show us what it means to execute a file and when you don't have the permission to do that. So I'm going to VI into file 2 right now. So
Hello.
okay,
Before
you can go on.
can I quickly ask? All right, I just need some guide on how to write this thing for my permission. So, share permission section 10 that says we should give access to all
I can't even
for
hear
the
you
two
clearly.
files. Okay, give me some time. Turn it on. Can you hear me now?
Kind of.
So,
Yes, you can go on.
okay, so I was saying in our in our project question 10 of the share permission that say we should write script that will add execution permission to the all subdirectories. So I was like thinking, how can I apply this knowledge now on that one?
You should write a permission that will what? Maybe you can
You
just
write
type
a
it in the
permission,
income message.
write a script that adds execution permission to all subdirectories of the current.
Okay, to all subdirectories.
Okay, all right.
Okay, I think that is where a flag will come in. You can check your manual. If you check your manual, I think it should be there. The flag you are going to pass. You know, we've been using our chi mode since without using a flag. A flag can come in the form of -L, -V, that is verbose, and so on and so forth. So right now, I don't know the command to use, but I'm very sure if you were to check the manual, you are going to see the correct flag that will actually tell you how to do that. So that's why we always ask any command we want to use, we should always check the manual to know comprehensively how to use such a command.
I've even tried downloading the version on my system. Let me download Microsoft Word. I'm
Trying to download on your system. We have a video on that on our YouTube channel. That's the CodeTribe YouTube channel. You can go through that on how to set up Vagrant for your computer, for your Windows operating system. And also concerning the question you were asking, you can just nobody knows it all. Definitely, you can just it's just your ability to look for resources by yourself. You can use Google, you can use any other method, just like you suggested the manual for to check what the appropriate flag to use. This is just the normal straightforward way to change the mode of a particular file. Then when it gets more complicated, like more deeper, then you can go. This is just we are just like teaching you the basic things you need to know. concerning file permission, shell permission. We can't definitely nobody can touch all, but you just need to make further research on your own, play around with this and that, and see whether it is working. Okay, but you can, in case you still run into problem further on, and you've gone through Google, you've gone through different, even the Chat GPT, you've asked the AI, the new AI that we have, and you still can't find the answer, you can then throw the question to your group chat or probably tag any of the admins. Then we'll definitely come to your rescue. All right. So, Mr. Samuel, you can proceed with your section.
Thank you very much.
Yeah.
So this file 2, I wanted to cut it out. It says no permission. It says permission denied. Why? Because for file 2, as a user, vagrant that I am, I do not have the read permission. You can see I only have the write permission to write into the file, but I cannot read the file. So, and I've actually written something inside. So let me just quickly change the permission for the user. Let me just say A plus. Let me add read permission for that file. So I can cut it out now. So now, this is what we have inside our file 2. Okay, so what's the file permission we have for file 2? Let me check that. Our file 2, we have a read write permission. So let me quickly do something just to demonstrate to us what it means to execute a file. So I'm removing the execute permission for this file for all. So no one can run this file now. So therefore, let me cut it out again. So this is what we have inside this file. File 2, as we have here, we do not have the execute permission for any of the sections, whether for our user, our group, or others. So therefore, how do you run a file? This file, you have to specify where it is, the file you want to run. So this file is in my current working directory. How do I specify that? I use a ./. This is showing me in this present working directory. This ./ is telling me whatever I'm going to write here is in this current working directory. So I'm now going to write the file name, which is file 2. So using this, should I say command, you are telling your bash you want to run this file. And the reason why I'll be able to run this file is because I've already specified the path here. And this file is going to do this ls-l command that I type onto my terminal directory. This file should do that for me. So now let me press the enter button. Of course, we are not expecting it to run. Why? Because this file doesn't have any word execute permission, just as we have here. So therefore, that is why you will remember in your projects when you want to upload them to GitHub, ALS will always tell you to type this command chmod u+x on your terminal and the file name. So when I type this, I believe everyone here should know what this means by now. So when I type this chmod, change mode, user plus what execute permission file 2, and I press enter, it means as the user that I am, that is Vagrant, this guy here, Vagrant can run this file now. So I'm going to rerun this command here, and let us see if this file will actually do this thing that I specified inside. This is a bash script. It says no such file or directory. Bad interpreter.
Your interpreter, you missed the /
/
after the exclamation mark.
Oh, should I put?
You missed the / after the
A
exclamation
slash.
mark. Yes.
Yes, I just saw that now.
Bash interpreter. Yeah.
Exactly. Thank you. Okay, I'm going to run that again. So I ran the file now, and we can see what happened. It says, I ran the file, and this command was executed, ls-l. This is what would have happened if I have typed the ls-l on my normal terminal. So I'm running this command using a file. Which file did I use? I used this file, this guy, file 2. You can see the command is inside. So you can run multiple commands using a what? A bash script. But if you do not know file permissions, then it can be difficult for you to actually run a bash script because you might not know how to change the permission of your file. Because of our time, we will not be able to go more than this on the symbolic method of changing file permission. So right about now, let us talk about the second method, which is the octal notation. So when you hear the word octal notation, in fact, let me touch file 3. So I'm just going to be cutting it out so we see file 3. Let me veer into file 3. So therefore, octal notation, when we talk about octal, it means numbers ranging from, octal means 8. So in an octal notation, the maximum possible number of numbers you can have obviously will be the base number minus 1. So that is the maximum number we can have according to mathematics is 7. So that means the file permissions that we have for any file can run within the range of numbers from a maximum of 7 to, in this case, is I think a minimum of 0. Yes, a minimum of 0. So I'll just quickly tell us what these numbers mean. Since we already know the symbolic mode of interaction, so we also need to know what these numbers mean. So I will start from 0. Octal notation. So 0 means no permission. 1 means what? Execute permission. All these things I'm typing here, you can actually get them on Google. So, and you can write them down, and if you don't remember them, you can always reference them on Google. So 2 means write permission. While we keep going, 3. So what is 3? Basic mathematics. What will make up 3? 2 plus 1. So therefore, it means what? Read and write permission. It's just you basically adding 2 plus 1. If you give it 3.
Write and execute.
Oh, sorry. Thank you.
Yeah.
Then we move on to
write
4.
and execute. Write and execute permission. You still will read. Yeah.
Thank you. So we go on to 4. 4 here means read. 5. Again, we add. What to make up 5? 4 plus 1. So that will be our read and execute permissions. And 6. What are we adding? What will make us 6? 4 plus 2, I think. Yes, that's 4 plus 2 will make up 6. That is read and write permissions. Then the maximum possible number in the octal notation that we can have is our 7. Seven should combine. What will make up 7? If 6 is read and write, and 1 is execute, so 6 plus 1, which will make up 7, will be read, write, and this guy here, execute. So therefore, 7, the maximum number of permissions we can have, read, write, and execute. What these numbers mean and how to use them in the octal notation, as we have seen earlier, in the in our manual, we are going to get down to the practical now. I should believe everything here should be correct. Okay. So let us just cut that out. That's file 3. Okay. So we said in the octal notation, so let me just use our ls minus l command just to show us the file permissions we have. So now let us use these commands, our 0, 1, 2, 3, 4, 5, whatsoever, up to 7 in the octal notation to change the permissions of our files. So how do you do this? You type your chmod command first, then you type number 1, number 2, number 3, then file name. This XXX can be any of these numbers. So it is a very straightforward command. Your change mode command, your XXX, the first number here refers to the user. The second number you will type will refer to the group. And the third number you are going to type here will refer to others. So this is the syntax you are going to follow. You see why I said that if you do not know the symbolic mode, it will be very hard for you to actually understand this mode. Because if someone is telling you X is user, and you are telling me, where is user? I'm not using U plus X, I'm not using U plus O, I'm not using U plus G. All those ones, they are not here. Your U, your O, your G, and your A for all, they are not here. We basically deal with numbers and file names. As per the numbers, you necessarily don't need to cram them. You just need to know your 0 means no permission, your 1 means execute, your 2 means write, and your 4 means read permissions, and 7 means all the permissions. Basically, if you know 1, 4, and 2, if we just add 2 of the numbers together to give you the desired permission. So now, let us actually change the mode of this guy, file 1, using a notation of 0 or true. So let me try that. Chmod 000, then file 1. Using this 000, I just specify that the user should have no permission, the group should have no permission, and others should have no permission. Let us press our enter button and let us list the files in the long format. And wow, we have this, no permissions whatsoever for this file 1. So you can see this command is even more tasking because you have to actually know what you are doing. It's not as so direct as the symbolic mode of us using alphabets or symbols, U plus X, U plus this, O plus this, G plus this. Here you basically write numbers, and any single error in the numbers, if you don't know what you want to do, you can actually compute the wrong permission for your file. So therefore, if I want to change the permission of this file to 777 this time around, I said 7 means what? All permissions, read, write, and execute permissions. So therefore, the same thing we are going to do. You come here, you change it to 777, and you tap your button. That's for file 1. And here we have it. File 1 already has what? All permissions for both users, group, and others. So I'm not saying if 7 is here, 7 must be here, and 7 must be here. It can be any different combination of the numbers we have above here. Any of the different permissions. You can have 112, 121, 131, 567, 732, but make sure your numbers will range from 0 to what? To 7. That's why we call this octal notation. You cannot have, okay, let's try that. Let's just say chmod 999, and let us see if something will pop up. We know this is a wrong permission for our file, but let us try that out. Can you see? It's telling us to do what? To go and check the help feature for Chmod because we just did what? We just wrote nonsense. So now let us change the permission for, okay. I want someone to this guy here, file 2. Let us do something a bit tricky and tasking. I want file 2 to have the same permission as file 1. No. Don't let me go with file 1. I want no. I want file 3 to have the same permission as file 2. What am I going to type? Okay, please, Mr. Abiodun, help us call someone. I want my file 3 to assume the file permission for file 2. That means file 3 must exactly. Okay, you said?
All right, we have your hands up. Andrews.
Okay.
Yeah, we are going to use the Chmod.
Okay.
Then the dash, a double dash.
Double dash like this?
Like, yes, no, there should be a space.
Okay.
All right, then come to the front of the dash.
Okay.
Then we're going to use reference.
Wait, you're already telling us the third method. We want you to use the second method.
Okay. Method. So you want file 3 to look like file 1?
We want you to use numbers to change the file mode of file 2 and file 3 to look exactly like file 2. Don't use the reference method.
It will be 7.
Okay.
744. Then the file name file 3.
So how did you arrive at this? Can you tell us?
All right, we know that the 7 is for read, write, and execute.
Okay, as we have here.
We know that, yes, that 7 is for, yes, the 3.
Okay.
Then we know that 4 is for read only.
Okay, that's for group. Thank you.
Yes, for group. And we also know that the another 4, that is the last 4 is for others, which is also read only.
Thank you very much. Oh.
All right.
So using this, we expect file 3 to take a file permission of 744, 7 for user, read, write, execute, 4 for read only for group, 4 for read only for others. So therefore, we type that in, we do our ls minus l, and here we have it. File 3 has the exact notation for file 2. That means file 3 has a 744 file permission. So someone can just tell you, I have a file and the file permission is 121. With that, you should be able to predict, you should be able to tell us 121 actually means this, 121 actually means that. So the hack to using the octal notation is that you should actually know what these numbers, what they mean in the file permission sequence. And I'm telling you, if you don't know the first group, the first method, the symbolic mode, it might not be so easy for you to just jump to this and start going with this. And if you know this is way easier for you, you can learn this and discard the symbolic mode. And if you believe you can learn the octal notation, this one, and also the symbolic mode, then you are good to go. So now, another person should tell us how we can change the, let me just say, for user equals to read, execute, then group equals to execute, then others equals to read, write. No, write, execute. So can someone give us this notation in the octal, this file permission in the octal notation, the octal method?
Okay.
And we should use that to change.
Yeah.
Okay.
We have your answer. No, finish your question. You should use that to check what.
Okay, we should use that to change the file permission for file 2.
Okay.
For our user must have RX, G, group must be X, and others must be WX for file 2. So
Yeah,
let's go.
yeah, that's 513.
513. 513.
Yeah.
So how am I going to type that?
Okay, like chi mode.
Okay.
Yeah, space 513.
513.
Yeah, what file I use? The file you want to use.
Second one is file 2.
Yeah, file 2.
Okay, please can you tell us how you got to arrive at this
Okay,
octal
like you said, user is read and execute, and in the octal notation, 5 is for read and execute. Then for the group, you said you want to just execute, and that's 1 in octal notation, and for the order, you said you want to write and execute, and that is 3 in the octal notation. So I think that's how I arrived at that.
Thank you very much. So let us type that in and let us see our file 2. So we said the user should be read execute. As we can see here, the group is what? Execute only, and our others is what? Write and execute. So that pretty much explains how you can use the octal notation to change the file permissions of files in your current working directory or files you have on your local computer.
Thank you, Mr. Samuel. Please, before you move further, concerning this octa notation, you don't need to cram it for now. You don't even need to cram it at all. You can just make reference to it from somewhere, because not everybody knows all the commands of Ed. The same way you can know this for now, but the more you use them, let's say these are what you use regularly, it will stick even without you thinking twice that okay, this is the octa notation for you to set the user group or others, this is the permission to use and stuff like that, or whichever method suits you. Anyone works. Okay, so you don't need to cram anything, just like you don't need to cram all the Uninos commands as well. So with time and practice and consistency, you will get used to all the commands and any other thing you need to know. I just said I should add that. So Mr. Samuel, you can go on. And we have
Thank you
one
very
hands
much.
up. Precious, do you have a question?
Not exactly a question, but I wanted to add, the numbers in the octal notation, they were derived by, I don't know if this was taught because I joined pretty late, but they
Okay,
didn't just
okay.
appear
I know
like
where you're
this.
going. There's a derivation for
Yeah,
this, okay, but we didn't
exactly.
really
So I
touch. We
feel I
didn't
feel
touch
it
that.
should be way more. Yeah. Okay. Thank you very
We've
much.
not touched that yet
Okay.
because we are
Thank you
running
very
out
much.
of time, and we probably will still have another section just to go into how these numbers are arrived. Okay,
Because
probably in another
it will be
section.
way easier to understand why the numbers stand for what they stand for when that is understood.
Yeah, thank you very much for that
All right.
observation. We'll work on that. Thank you very much. So Mr. Samuel, we are really running out of time, but you can just do your thing. Don't worry.
Okay, I will be rounding up very soon. So from our manual, the third way we said we can change the file permission of our files or scripts is using the third method before the reference method. So basically, like I said, using the reference method, you are trying to change the file permission of file A in respect to file B. So in this case, let's just show an example. Most of the times it follows this same command. You type your shmode command, then we use the double dashes like this. Then we use our reference, we call it here. Then we are going to call the file we are referencing. Let's say we want whatever file we want to change the permission to be exactly like file 3. Then we are going to pass the file we are referencing here. That is the file 3. We are going to pass it here. Then we type our space. Then we now pass the file we are changing. That's basically everything I would just say about using the reference method to change the file permission. So let's just try that with an example or two because of our time. So, okay, I don't close the quotation. Is it a single quote I used? Okay. Okay. So using the reference method, we have our chimo dashes, then we have the reference equals to what? What are we referencing? Let's say we want to change our file 2 to look exactly like file 1. So this is our reference file. We pass in file 1 as our reference file. Then we pass in the file we are changing, that is the file 2. Then we press enter. No errors. Then we use our ls-l command. Then we check for the file we just changed, this guy. This is it here. You can see the permission has changed in respect to that of file 1. So this is also a way you can change the mode or the permissions of a file directly by using the reference of another file. So you can pretty much play around with that as well and can change that of file 3, file 2 with reference to that of, you can change the permission of file 2 with reference to that of file 3. That means 3 is going to copy exactly, file 2 is going to change and copy exactly the file permission of this guy that is here. So let's just do that. File 2 is going to change as expected and is going to take the exact same permission file 3 is taking. So basically, in summary, what have we discussed today? We have been able to see that file permission is an essential aspect of Unix-like computer systems, and it can serve as a way or as a security feature and to prevent intruders from accessing what they don't have access to. So it's like a privacy setting, just like you have your password on your devices or when you lock your file using an app lock or whatever. So you can also change the mode of the file so that no one can read it, access it, edit it, or even view it as the case may be. The same thing you can do for directories as well. And we have also been able to see that we have the file permissions. We can see them when we use our ls-l command. And we've been able to see that when it starts with a D, it's actually referring to a directory. And when it starts with a dash, it's referring to a file. We have also been able to see that the permission indicators, they are in groups of 3. We can have our R, we have our R, W, and X. R stands for read, W stands for write, X stands for execute. And when we say execute in terms of directory, it means you can CD inside the directory. That's when the execute permission is actually activated. When we're talking about execute for file, it means that you cannot run that file as a script or in any other way. It means you cannot run that file. And we showed us how you can run the file using the // when the file is in your current working directory. We have also been able to see what these characters that are here, what they signify for our files or our directories that are in our current working directory. We have been able to see that the characters 2 to 4 refers to the file owner permission. We have also been able to see that characters 5 to 7 refers to group owner permission, while 8 to 10 refers to everyone else or anybody. We have been able to see 3 ways in which we can change the file permission of our files. We have been able to see the symbolic way using our U G, O, and A symbols, that is the symbolic mode. And we have also been able to see the octal notation using specific numbers ranging from 0 to a maximum of 7. And we have also been able to see the last way using referencing method to change the mode of files we have on our system. So that is basically what we have been able to discuss this evening. I don't know if you have questions.
Okay, we have Silas. Is that your name? Bauer. Okay, let me just call you Bauer. So you can unmute your mic and talk, ask your question. So thank you very much, Mr. Samuel. So we'll be taking your questions now. Bauer. All right.
Okay, I don't know kind of feeling to forget me this history, but I was just like, the same material that you guys use that you have used, or how do you explain it? Like, if there's a material, please, I'd like you to share so that I can read it too.
Okay, I believe you are asking for the materials that is able to the
Yeah.
okay. All right, probably Mr. Samuel will get back to you, probably upload the material for you. You can also source out materials on Google, watch tutorials on YouTube or thereabouts, or just yeah, there are lots of materials out there,
All right. Thank you so much.
depending on the one that you can easily grab. Okay, Akomolafe,
Yeah, sorry, I want to ask the presenter. I that part when you remove the permission for execute on the directory, what does it mean?
Mr. Samuel, I think this question is for you.
Okay, all right. The other time we said when the execute permission for a directory is removed, it means you cannot actually enter into the directory. Unlike a file, when you remove the execute permission, you won't be able to run the file. Same thing for a directory. In this case, you know, we cannot run a directory, but in this case, it means you will not actually be able to enter or see into the directory. For now, I can see the inside the directory called directory. You can see I'm inside, but when I remove the execute permission, let's say I change it to 444 for the directory, and I try to see the inside, you can see it's giving me permission denied error. Or so that's just what execute for a directory means. It means you can't enter it, you can't access it, you can't see the inside it.
Thank you so much.
Yeah.
All right. So do you have any other question before we call it a day or a night? Probably there will be another section tomorrow. Just like okay, Precious is no more here. He raised up something really wonderful. How the octal notation numbers were being derived. I believe it can also be a added knowledge in order for us to know how those numbers did not appear magically. They came from somewhere. They came somehow. They are being derived in a way. So probably tomorrow I will talk to the resource person if he can handle that section, even if that's the only thing. I'll probably take more questions from anybody that is still having difficulty in the shell permission, understanding shell permission. So is there any other question before we call it a night? Okay, Bauer. Yeah, go ahead. You can unmute your mic. Your mic is muted. I actually muted you when you finished on talking the other time. So you can unmute your mic and ask a question. We have just about 5 minutes. We want to end this section in 5 minutes. So I believe you don't have a question then. So tech science chair or something. Just tech. Okay.
Please, how do we change the owner?
The owner, in what way?
Yeah. Is it?
You want to change the owner to what?
Let's say
Your line is breaking.
please, can you hear me?
Yeah, go ahead.
Oh, okay. Let's say we want to change the owner to, let's say, group settings.
Oh, okay. Mr. Samuel, I think you want to take that.
Okay, actually have a command to change owner and to change group. You can use the change owner command, CHOWN command. Some people call it the chown command to change your owner. That's if you have more than one owner, but my system I only have Vagrant as the owner for my system. So if you have more than one owners or users that are using your system, you can change the owner of a particular file. You type the CHOWN command and you specify the new owner that you want the file. The new owner, then the name of the file following it. The same thing for your group. You use your change group, I think CHGRP for
Yeah,
that. To change the group of
yeah.
a particular file too as well.
Okay, probably tomorrow's section will cover the remaining part of this shell permission aspect that we skipped for today. So, I guess that will be all for now. Tomorrow the resource person is going to just continue from here and talk about the other shell permissions that we skipped for today. Then, so take care of yourself, guys. Thank you very much for joining this section, and we hope to see you in the next one. So good night and happy coding.